everyone, Joanna Wilson here for my OCR A-Level Chemistry Manual. Today we're going to be looking at Section 9, Organic Chemistry and Analysis, and we're focusing in on spectroscopy.
Just work, shooting.
So, quite a lot of outcomes for this session. They are to be able to describe how NMR spectroscopy works, outline the information that can be gained from analysis of an NMR spectrum, describe the difference between carbon and proton NMR and what extra information can be gained from proton NMR, predict the carbon or proton NMR spectrum for a given molecule, describe the use of TMS as a reference for NMR, outline the need for deuterated solvents when running an NMR spectrum, and describe how techniques can be combined in order to identify an unknown compound. So, NMR spectroscopy then, 1% of carbon atoms are the C13 isotope, as we know, and most are carbon-12. Now, the effect of this is that the carbon-13 nuclei behave like little magnets, and they will respond to a magnetic field if one is applied. So, a carbon environment is known as the atoms that are bonded to each carbon will have an effect on it. They may pull electrons towards them, making the carbon more positive, and they will affect the environment that the carbon is in. When a carbon atom is exposed to radio frequency energy, it will resonate at a particular frequency, and this frequency will be different depending on the carbon environment that we described above. And through measurement of this resonance frequency, we can determine the environment of the carbon. So this is an example of a carbon NMR spectrum, and the features are 3 peaks. The one at 0 is a reference peak, which we're going to be talking about in a second, and the other 2 peaks indicate that there are 2 different carbon environments present in this compound, and the scale on the x-axis is known as the chemical shift and splits the environments up based on their magnetic field, and this is required to make the carbon resonate. So we've actually got the molecule here that is being shown in this NMR spectrum. How do we know which carbon atoms it's referring to? So firstly, tetramethylsilene, TMS, is what we use as a reference. So the peak at 0 is known as the reference peak, and it comes from this molecule, and it's been chosen as a standard for several reasons. So they've got 4 carbons in the same environment, so it's a really strong signal. Almost every other environment will be on one side of it on the axis, and the peak will be at an extreme right hand side, meaning everything can be referenced to it easily. This peak may be on the left of the spectra that you are given, however it's a large peak at 0, likely to be the compound. Thank you so much for watching this teaser video for the OCR A-Level Chemistry Manual. You can now click the link down below to download the full manual. Please check it out now. Keep smashing it, and remember, anything is possible if you just work. Bye!